Hello everyone, and welcome back to the Kohi Game Engine series. Today we are going to focus a little bit more on the instance creation as well as some things surrounding that. So let's go ahead and jump in. Really quick though, I would like to take a quick second and thank the partners of the channel, Eearslya and Wensheng. The partner is the highest tier of supporter on the channel. And so I just wanted to say thank you to our partners as well as our other supporters that are listed here on the screen. So if you're interested in supporting the channel, there are a couple ways to do that now. First off, I have channel memberships available. You can access that by clicking the join button below this video. I'll also provide a link to a video that I have describing the memberships. And I also have a Patreon page, which is patreon.com/Travis Vroman. Thank you all very much for your support. It is greatly appreciated. So last time we successfully created our Vulkan instance, but there were a couple of things that I sort of left out just to make sure that we could quickly and easily verify that all this works. So now we're going to go ahead and fill those things in. Most notably, these things here that I set to 0. Now, one of you did call out that I didn't need to set these to 0 because I'm already 0 initializing everything by doing this, which is true. However, I wanted a visual reminder to myself that I still need to fill these things out, so I actually left them in place but assigned 0. So, what we need to look at is extensions and layers. In Vulkan, if you recall our initial conversation, Vulkan is designed to be extremely lightweight and cross-platform compatible, meaning it doesn't have a whole lot of things that we're going to need in its core. So what this means for us is we will need to load some of these things ourselves. One of those things is going to be an extension that we're going to require. Actually, we're going to require a few extensions. And extensions are basically libraries of code, or you can think of them almost as plugins to Vulkan that extend its capabilities. So for example, we're going to have an operating system specific extension that we're going to use for windowing. So there'll be one for Windows and one for Linux. So we're going to go ahead and make sure that those things get loaded appropriately. The other thing is these layers. And these layers are what are called validation layers, and they are what we use for debugging. Now, by default, Vulkan does not provide debugging information. And in fact, it doesn't even validate that the data that you pass to it is correct. Under most circumstances, it'll just crash and not really tell you anything. And so what we need to do is we need to use some validation layers, which thankfully are provided with the SDK but not loaded by default. And those will help us along the way on our development journey in troubleshooting our code, because we're definitely going to shoot ourselves in the foot along the way. And so this will sort of help us heal those wounds, as it were. So we need both extensions and layers, so we're going to get both of those things stood up and then loaded into these. So we have an extension count, or an enabled extension count, and then a pointer to an array of extension names, which is just it's a constant pointer to a constant character array. So basically an array of character arrays. And then the same thing is true for the layer count and then the layer names. So all these things are loaded by name, and the way that we're going to set this up is there are going to be certain of these extensions and layers that we're absolutely going to require, or otherwise the application will not load. So if we don't have those things in place, we're not going to continue loading the application. This is more so true for the extensions than the layers. The layers we're only really going to do on debug builds, but the extension counts, rather, those have to absolutely exist, and they will exist because they come with the Vulkan SDK for the particular platform. So with all that out of the way, there are a couple things that we need to do within our Vulkan backend and sort of external to it to support some of the functionality that we're going to need. So since we're working with strings, we are going to want to go ahead and also include kstring.h, which we haven't fully filled out, and I've decided that I'm not going to dedicate a video to that. We're just going to fill in that function as we need it. So we're going to need that. We're also going to need our containers D array because we are going to be making use of that as well. And that's going to mainly be used for these arrays that we're going to fill out here so that we can safely dispose of those things later. And we're going to need some other stuff. In addition to that, we're actually going to need platform as well, because there's actually a bit of platform specific code that we're going to have to load here. But thankfully, we'll be able to go ahead and abstract the platform specificness behind the platform layer. But we do actually have to make a call into our platform code, so I want to go ahead and get that in here as well. And that should be it as far as the includes that we need to add to this file for now. We will definitely be coming back to that, but for now, that's good enough. So the next thing I want to do is I want to go into our kstring.h because we actually need to add some functions here. For now, the one we're going to need is just a simple check to see if two strings are equal to one another. And so this, for now, is just going to wrap the standard library's string comp. And we're basically going to return true if the difference between those is 0. Otherwise, we're going to return false. We probably will be writing our own one of these eventually. But for now, I'm just going to go ahead and wrap the standard library version of this. Okay. So I believe that is actually all we need for right now, but I will keep this open just in case. So heading back to the Vulkan backend. Before we actually fill out these create info structures here, we actually need to create a couple of arrays. So I'm going to go ahead and do the extensions first. And so I'm going to just set up an array, a D array of a constant character pointer type, and call it required extensions. And then I'm going to go ahead and push an entry to that. Now, so this VK-KHR surface extension, this is the generic Vulkan extension that Vulkan uses for surfaces to render to. But we also need an operating system specific one. And that is going to be provided to us by a function we haven't actually created yet called platform get required extension names. And this is going to pass to it the address of our array here for required extensions. That way I could just add it to that D array and we can move on from there. The next thing that we're going to want to check is if we are in debug mode, we are going to load one more extension. And this is an extension that we use specifically for debug logging, and we will get into the creation of this in a bit, but since we're sort of loading up our extensions now, I want to go ahead and get it in here. So I've wrapped this with a debug check to see if underscore debug is defined, which it will be in debug builds. It will not be in release builds. And we go ahead and push this VK extension debug utils extension name to that list as well. So that's the reason we're using a D array here, just so that we don't have to worry about potentially not allocating enough memory or allocating too much or any of that stuff. This is a nice simple way for us to go ahead and do that. Okay, great. So these are the required extensions. So one thing that we're going to do is if we are in debug mode, I'm also going to put a little bit of extra code in here to print out the required extensions to the log, just as a debug string, right? We're not going to bother with this in release mode, but this will give us just a visual as to what we're actually requiring Vulkan to be able to load to run the application. And that may be useful to us at some point. All right, so now that we have our list of required extensions, we're going to want to replace this extension count with a call to darray length for required extensions. And we're also going to want to set the PP enabled extension names to use required extensions instead. And this is what actually tells Vulkan to go ahead and load those extensions. Okay. And so now we will have validation layers next. But before we do that, we need to fill out this platform get required extension names. So that is actually what I'm going to do first. So the Vulkan platform layer sort of gets a little bit weird, right? Because what we have is we sort of have this renderer API abstraction, right, where we try to keep Vulkan from being known about other parts of the system. And then we also have this sort of platform layer where we try to abstract the platform, right? But the Vulkan platform layer, which is what we're going to call it, is sort of a mixture of the two. And so this gives us a little bit of a weird overlap between those two, where we kind of have to know about both of them in one spot, but we don't necessarily want to cross-expose all those types to each other. And so what I'm actually going to do is I'm going to, instead, under our renderer within Vulkan, I'm going to create a new file, and I'm going to call it vulkanplatform.h. And this is actually where the platform get required extension names is going to list, right? And there are going to be a couple things we need to add to the top as well, which is our pragma once and a include for defines.h, which we're going to need later. So the way that this works is this takes a triple pointer, which is a little bit weird, but it makes sense when you think about it. So we have an array of character arrays, right? So a string is a character array, so that's one. And then we have an array of those things, right? And then because we're modifying that array, which exists elsewhere, we need a pointer to that array. So what we wind up with is a triple pointer. But if you follow that logic down, it sort of makes sense, okay? And so this platform get required extension names is how we're going to handle this. Okay. So naturally, you might expect that we may add a Vulkan platform C here, but we're not actually going to do that, right? Because we actually do want to keep the sort of backend implementation of this out of Vulkan. And so what we're going to do is we're going to go to our platform layer. In this case, I'm going to start off with platform Win32, and we're going to put it in here because remember, it doesn't actually matter where this is declared or defined. The file names do not have to match or anything like that. We can put them anywhere. And it makes the most sense for us to put the implementation of this function in platform win32.c. Right below platform sleep, we are going to put in our platform get required extension names. And all this does is calls darray push, which we actually need to include darray. So let's do that. Okay, it calls darray push, and it passes our names array, and then we pass it this vk-khr win32 surface. So this is the operating specific extension that we need for a surface to be able to render to. And we're going to cover surfaces more in depth later, but we can't create an operating system specific surface without loading its extension. So that's what we're doing here. Okay. And since we are sort of doing the platform specific stuff, I am actually going to go ahead and cheat a little bit and do the Linux version here as well, simply because it's only a couple of lines. And so it's really sort of easy to just jam in here now. So I'm going to put this in the same spot right after platform sleep. Here's the Linux version of that, right? So it does the exact same thing. It just uses vk-khr xcb surface. Now, if we're not using xcb, you can also use xlib, but in our case, we're going to actually be using the xcb surface extension. So I put this comment here in case you want that for some reason, but if you're using Wayland or something else, you could, I think there's extensions for those too, but for now, this is all I'm going to support for here. Obviously, we have darray, so we need to make sure that we include that here at the top. Okay, and that pretty much does it, at least for now, for our platform layer. Okay, so back in our back end, it occurs to me that I actually included the wrong file here. I included platform.h. I don't think I actually need that one. I think what I actually need is going to be, what we actually need is Vulkan platform.h. And now when we hover over this guy, we get the appropriate name. Okay, so that is all of our extensions. Nothing too terribly complicated there. Okay, so now that we have our extensions, the next thing that we need to do is our validation layers. And validation layers follow a Somewhat similar process, although there's a little bit more processing that we have to do. Before anything else, we will obviously need an array for that, right? So first we're going to start off by initializing this to 0, both of these to 0, because we may or may not actually be loading these. And we're going to copy these values to our create info struct down here, right? Because we may or may not be filling this out depending on whether we're running in debug mode or not. So I want to go ahead and make that connection now. And then the next thing that we're going to do is I'm just going to paste in a block of code here. This is what does all the work. So if we are in debug mode, then we will want to go ahead and perform validation. So we go ahead and say validation layer is enabled, just to give us a little bit of feedback. Here is where we actually initialize the array. We pass to it the VK layer Chronos validation, so that's a validation layer. We can pass in more than one of these, but that's the one we're primarily going to want for now. We can always add to this list later. And then the layer count is, of course, the darray length of that. So the next thing that we have to do is we actually want to verify that the validation layers exist. So to do that, we query by vk enumerate instance layer properties. We pass it the address of the available layer count and null. So the next thing we do is we create a vk layer properties array, and we're just going to reserve that for the available layer count just to cut down on reallocations. And then we're going to go ahead and call this vk enumerate instance layer properties again, passing again the layer count, and this time passing the available layers. Okay, and that will give us our total list of available layers. Okay. And you'll note in here that I actually have these VK check. We're actually going to come back to that in just a second. I know we haven't defined that yet, but I'll come back to that. So what we do is we loop through all of the required layers, and we say, hey, we're searching for this layer. And then we basically look through all of the available layers, check to see if the strings are equal, and then if we found it, we're good. If we come across any layers that we're requiring but are not found, we go ahead and throw a fatal error and return false. Otherwise, we say all validation layers are present. So this is just a quick verification that the validation layers that we're looking for actually exist. And of course, as before, we go ahead and assign those things down here to our info, and we're good to go. So if we get down here, we are pretty much good to go on that. So now this VK check. We have this pattern down here which isn't 100% correct, and I did mention that before, because technically speaking, there's a wide range of results that we could expect here with different error codes and things like that. We want something so that we don't have to constantly repeat this code, right? And then have this if statement in here and have this all throughout our code, right? That's kind of annoying and repetitive. And so we're going to write something called VK check, which is going to be a simple macro that is going to do this basically for us. Okay, and so we are going to put that in Vulkan types INL, and I'm going to put this towards the top here. And all it's going to do is it's going to take whatever expression is passed in and check that against VK success, right? So it's just going to sort of clean that up a little bit for us. So now back on our back end, we can use this VK check, right? And so we can now replace all of this with a VK check, right? And then if our VK check fails, then we throw an assertion, and we don't need that if check, right? So anywhere that we're using VK check and it fails for some reason, and we only care about the success, this is just going to be a sort of shortcut that we can use without having to sort of repetitively check for that stuff all the time. So anyway, let's go ahead and build this. And it looks like we have some errors here. Implicit declaration. Oh, I think I forgot to include there. So let's go to Vulkan types, and right under defines, we'll put core certs, and build again. And there we go. Okay, so I'll go ahead and run. Okay, and as you can see, our debug text is coming up here. And we can see here that these are all of the required extensions that we need. So we can see our list is working properly. And we can see that our validation layers are enabled, and we are enumerating those things, looking for VK Kronos validation. We found it. We are good to go. So all that is working properly. We are initializing as we're supposed to be. So that is all looking pretty good. So given all that, we are actually doing pretty good on time. So I'm actually going to move on and put something else into this video that I wasn't sure that we were going to have time to do. So the next thing that I want to do is I want to create a Vulkan debugger. And a Vulkan debugger is basically a logger of sorts that we can put into place. Let me close this, get that out of the way. That we can put into place that will give us additional information about Vulkan and the things that are happening under the hood. If the validation layers run into some sort of an error, this is how we're going to retrieve the error information about that, right? Because we have our instance created, we have our validation layers loaded, but the validation layers actually have to log to something, and the debugger is that something that they log to. And so we actually need to go ahead and add a debugger here. So right after our Vulkan instance is created, which actually, let's be a little bit more specific about this, and I'm going to add a debug message here. Actually, I'll add, so I'll be a little bit more specific here, and I'll add a Vulkan instance created output there. And then right after that, we're going to go ahead and create our debugger. Okay. Now, you'll see here that there's a couple of things that it's bleating about, but let me basically quickly explain what this does, and then we'll fix those problems. So first off, we only want the debugger obviously in debug mode, because we wouldn't have loaded the extension otherwise. Next, we are going to choose our log severity. So Vulkan has a few different levels of severity and what you can log. So there's error, which is basically like a fatal type of error. There is a warning, which basically allows the application to continue, but it's something that might not be ideal, and sometimes it can cause potentially a crash. But errors, technically, you can't. So errors are basically always a crash. Warnings, usually not, but sometimes they can be. And I've gone ahead and actually commented in here the other two severities, which is info, which is basic information that it will feed out to us, and verbose, which is extremely verbose. We'll only use that if we have to do some advanced debugging. So I may wind up turning this one on just to show you guys what that does, but verbose, I've not had a need to actually turn it on as of yet. So the next thing is, since we're creating debugger, we obviously need a creation info for that. So we have a debug, VK debug utils messenger create info ext, which stands for extension, because this is an extension we're loading. And of course, this takes a VK structure type, blah, blah, blah. I'm not going to go through that again. We pass in our message severity, our message type, which basically allows us to filter what message types we actually want. So we want general messages, we want performance messages, and we also want validation messages. So we can actually use this to filter down. I'm going to turn them all on for now, but we don't necessarily have to do that. The next is a user callback. In other words, when it receives a logging request, what does it do with it? So that is going to be this VK debug callback, which we've not yet defined. We'll come back to that. And then the p user data I have set to 0, which is actually not needed because we're setting it to 0 here. Next, of course, we will need to call our VK create debug utils messenger. However, since this is an extension, it is not automatically loaded by Vulkan. Therefore, we will need to load a function pointer to it. And this is the way that we do that. So we have a pointer function type here, and we just call it function, and then we say get vk get instance proc address, which is basically a pointer to the function. We pass it the instance, and then we say this is the function name we're looking for, and it returns a pointer to that function. We then check to see if it exists, because if we type this wrong, it'll come back null, which would cause this assertion to kick off. We then call vk check against the function, and this particular function requires the instance be passed, the debug create info, our allocator, and a pointer to our debug messenger. Now, I do want to make a note that we actually haven't set this up yet, so I'm going to have to set that up as well. That is why we have an error here. So we're going to actually keep a copy of this debug messenger in our context. So I'll set that up in just a second. And then, of course, we just log something out that the Vulkan debugger was created. So let's go ahead and set up the debug messenger first. So I'll go back here to Vulkan types INL, and we are going to put in here right after our allocator. If we are in debug mode, then we will add this to the structure, right? And this is just a simple vk debug utils messenger extension, right? This is a handle to the debug messenger, if you will. Okay, so if we're in debug mode, this will be defined, otherwise it won't be. And so now when we go back here, that error is resolved. So the last thing that we need to set up for a debugger is going to be the handler for any messaging events that happen. So this one, since it's a sort of a utility function that we're really going to have to just create once and not really think about it, I'm going to put this all the way at the bottom of the file. And basically this takes in the message severity, the types of messages that we're dealing with, and then the callback data, which is the message itself, and then any user data that we pass along. So if we had filled out that user data, we could maybe contain a pointer to the application or something if we wanted to do that. In this case, we don't need any of that, so I'm just going to not use it. So basically what this does is it takes the message severity and runs it through a switch case, which allows us to forward it to the appropriate logger, right? So error obviously goes to error, warning goes to warning, info goes to info, and debug I'm actually forwarding to trace. Verbose I'm forwarding to trace. Okay, and then per the spec, we're also always supposed to return vk false from this callback. I don't know why they have us return a Boolean, but it always is supposed to return false. That's what the spec says, so that's what I'm going to do. Okay. Now, obviously, since we're defining this after where it's actually called, that means that we're going to need to go to the top of the file, and we're going to have to forward declare the signature for that particular function, right? And so once we do that, we can come down here and we can see that all of our errors are resolved. So let's go ahead and build this real quick, and we'll run again. Okay, and we see here that our Vulkan debugger was created, but we don't actually have anything to sort of validate that our debugger is actually working, right? So why is that? Well, it's because we're not actually making any other Vulkan calls at the moment. So basically when we create our instance, we're creating it before we created our debugger, right? So we're creating our instance, then we're creating our debugger, but then we're not really doing anything after it. So, okay, so we have our Vulkan debugger created, and unfortunately, until we move on to the next part of this, there's not really a way to validate that it works. We're just going to have to sort of accept this at face value that it works, and we'll see shortly that it in fact does. And if for some reason it's not working, we'll see that as well. One more thing that I wanted to point out that I didn't quite get to is the shutdown. So we've created our Vulkan instance, right? And we've created now our debugger, but we didn't actually do anything in our shutdown, right? And somebody had pointed out that I didn't do this, and it was kind of intentional because that last video was getting a little bit long. And so what I'm going to do is go ahead and put that stuff in here now. And generally speaking, you're going to want to destroy your resources in the opposite order that you created them in. So since we created our debugger last, we're actually going to wind up destroying that first. Okay. And so to do that, we simply are going to output something saying we're destroying the debugger, check to make sure it exists, obtain a function pointer to the destroy debug utils messenger extension function, and then go ahead and call it. All right. And then, of course, we're going to want to finally destroy the instance. Now, you could argue that technically you don't need to do this because by closing the application, it destroys all this stuff for you, but I prefer to not rely on the driver to actually do that for me. I prefer to be explicit. So remember, all this stuff works through the GPU driver, and if something isn't necessarily right there in terms of freeing resources, not doing this could be a problem. So let's go ahead and run. And I'm actually going to go back to our main function here. And I'm just going to stop the application right before we close it. Okay. And so now we have this. And we see here that we are destroying our debugger and our instance, right? And we are successfully shutting down. So that is pretty much all I wanted to show in this video. Next time, we're actually going to get into something that's a little bit more interesting, where we are going to go ahead and obtain the physical device, which is the graphics card itself. We are going to obtain that. We are going to query some information about it, such as how much memory is available on it, things of that nature, what features it has. And from there, we will go on and create a logical device, which is sort of the application's view of the device, which is going to be a recurring theme as well. I'll get more into that when we get there. And finally, from there, we'll go ahead and get started setting up the other pieces of the puzzle that we'll need to actually get something at least clearing to the screen so that we know Vulkan is stood up correctly. So anyway, thank you guys so much for watching. I hope you learned. If you haven't already, go ahead and hit the like button, consider subscribing, and go ahead and hit the little notification bell there so that you get notifications as to when the next video in this series drops. And I will see you guys next time.